Hi everyone, today I will start with the chapter periodic table, and in this chapter we will be majorly discussing about the modern periodic law, periodic properties and the basic trends in periodic properties. Modern day periodic law states that physical and chemical properties of elements are periodic functions of their atomic number. And it is this law on which the periodic table is based. Okay, it was proposed by scientist Moseley. So scientist Moseley arranged the element on the basis of their atomic number. Before this, scientist Mendeleev also proposed a manner of arrangement of element. Mendeleev stated that periodic table is arranged on the basis of atomic weights. Okay, and later on Moseley said that it is the atomic number which are the periodic functions. Okay, now let us revise this part once. If we consider an element, suppose X, so this is an example where the mass number is going to be 12 and atomic number is 6. Now this value is equal to the number of protons, also equal to the number of electron, and this is only our atomic number, and this 12 atomic number, and this value 12, this is going to be our mass number. Okay, so mass number is what we write as atomic weight. So an element represented like this means this. So like this we can arrange our periodic table, which has 7 periods and 18 groups. This is the picture of our modern day periodic table. Okay, these are 7 horizontal rows of element, 7 horizontal rows of elements known as periods. So these are our periods, 7 periods, and we have got 18 columns. So 18 vertical columns are known as groups. Okay, so 18 groups and 7 periods. Fine. Now some information, write down. Shortest period is the first period, period 1, with 2 elements, hydrogen and helium, period 1, hydrogen and helium only. Number 2, the longest period is period 7, the last period. Okay, period 7, it contains 26 elements. Okay, next our group 1, these are known as the alkali metals. So example of alkali metal from group 1. Group 2, these are known as your alkaline earth metals, beryllium, magnesium, so on. Okay, next comes group 3 to 12. These are your transition elements. Okay, next will be our group 13 to 16. It contains your post transition elements. Next is group 17, contains your halogens, fluorine, chlorine, bromine, so on. Group 18, this contains all the noble gases, helium, neon, so on, noble gases. Okay, now just to clarify, let us consider example. Suppose sodium. Okay, it has got atomic number 11. How can we arrange 2, 8, 1? So this is our electronic configuration. So you should know how to arrange it. Okay, 281. So this part is very important. Arranging is important. Next, suppose magnesium. Magnesium is 12. Atomic number is magnesium is 12. So I can write it as 282. So you have done this in previous classes. So you should know this part. Okay. Period number signifies the number of electron shells of an element. Let us consider an example. Sodium. Atomic number is 11, which can be written as 281. Okay. So number of electron shells is 3. So period number is also equivalent to 3. Okay. See, 281, 3 shells. So period number will be 3. Similarly, group number signifies number of valence electrons of an element. Let's consider the same example, sodium. Atomic number is same, 281. Okay. So the group, or wait, just a second. Yes, so your valence electron is equal to, that is the last electron, right? The electron in the last shell is equal to 1. So your group number is also equal to 1. So whatever is the last electron, that is your group number. Fine. Property trend along the period. See, from left to right along the period, what happens is your number of electron shells remains the same. Fine. For example, lithium and beryllium. Lithium is 2, 1, beryllium is 2, 2. Okay. See, the number of electron shells in both case 2. So period will be equal to, period is equal to 2. Property trend down the group. Down the group is means from top to bottom. So we are moving down the group from top to bottom. Here the valence electron remains the same. Let's, for example, sodium, which is 281, and potassium will be 2881. Check the last electron, 1, 1. So your group will be 1. Now the difference, see, number of electron keeps on increasing. See over here, lithium is 2, 1, beryllium 2, 2, next will be 2, 3. So what's the difference? Electrons increases. And here the difference is number of shells keeps on increasing. Okay, check the example, 281, 3, and here will be 2881. So 4. Periodicity in properties of elements. What does this term mean? See, the occurrence of characteristic properties of element at definite interval in the periodic table when the elements are arranged in increasing order of their atomic number is known as periodicity. Periodicity simply means some behavior gets repeated after a definite interval in the periodic table, and this is only going to take place when elements are arranged in increasing order of their atomic number as stated by Moseley. Okay, and what is the basic reason behind this occurrence? So basically, when the elements are arranged in the similar valence shell electronic configuration. So valence shell or the last shell electronic configuration when gets similar, these properties also have got a particular trend. Okay, and there are 4 major property in our syllabus. First is your atomic radius, then ionization potential, electronegativity and electron affinity. So these are the 4 things we will be doing in brief. Our first periodic property is atomic size. This is the distance between the center of the nucleus of an atom and its outermost shell. So see, if I draw a nucleus over here and the shells, then the distance from the nucleus to the outermost shell is the radius. Okay, this is our atomic radius. Now there are some factors on which it is going to depend: number of shells and nuclear charge. See, as your number of shells increases, then the distance also will increase. Distance between nucleus and outermost shell or the valence shell will also increase. Hence, your atomic radius will increase. So, it is directly proportional. Simple. Next is your nuclear charge. Okay. What is the nuclear charge? It is the amount of charge that is exhibited by the nucleus of an atom. That is your nuclear charge. So, if I draw the nucleus over here, it is going to contain positive charge, and these are your shells, which is going to have negative charge. Now, the positive charge is of the proton. Neutron also present, or proton is having your positive, and neutron is chargeless, so it has got no charge. So, it is overall the proton which is affecting the charge. Okay. And the negative charge is specifically because of the electrons present. So, positive and negative is going to attract, positive and negative attracts each other, fine. Now, greater the positive charge, greater will be the attraction. This is your atomic number, okay, or the number of protons. So, positive charge is the number of proton only, fine, okay. Now, this negative charge is the number of electron that is present in the valence shell, fine. Now, this thing basically means that greater is your positive charge, greater will be the pull of the electrons by the nucleus. So, write down over here, when nuclear charge, that is your positive charge, keeps on increasing or increases, then attraction for the outermost electrons also increases, okay. So, this is your increasing attractive force. So, the attraction will keep on increasing, and hence atomic radius will decrease. Why? Because the attraction is happening. So, therefore, automatically the size will decrease. This is your attraction between the positive and negative charge, right. So, pull is going to take place, and thereby the size is going to decrease, and this is how these two factors will basically affect your atomic size, okay. Let us try to consider the elements in the periodic table. Suppose, for example, the distance between these two shells is equal to 1 in lithium. In sodium, the value is increasing by 1, 1 and 1. This is not the actual one, I am just considering for atomic radius. Suppose this is, for example, it is equal to 1. So, the value here is 1. Next, it is 1 plus 1, that is equal to 2. So, the value increased here 1, 1 and 1. So, 1 plus 1 plus 1, it is equal to 3. And in this case, the value is going to be equal to 4. Okay. So, down the group, since the number of shells are increasing, down the group, the size will keep on increasing because of increase in the shells. And here what is happening? The electron is going to increase. So, this is your negative charge, okay, negative charge over here, and we have got proton which is pulling this negative charge. So, basically the proton attracts the negative charge, okay. So, as we move from here to here, the negative charge will keep on increasing, keeps on increasing, okay. So, we can write the positive charge then pulls the negative charge with greater attractive force, okay. Hence, size decreases, okay. So, the size along the period is going to decrease, size decreases because of the pull. I would like to end this video over here. In the next video, we will be discussing about ionization potential, electron affinity and electronegativity. these are the leftover periodic properties we have. I hope you like this video. Thank you.